So we've been talking about the function, right, in section 2.3. Now, let me make a revision of what we did. So yesterday we talked about the domain of a function, range of a function, right? Now let me take a function. Okay, so this is our example. This is the exercise, okay, number 62. So we have a function f of x equal 2 over x square minus 9. So this is a function we have, and we are asked to find the domain of this function. Now, who can tell me what does it mean by finding a domain of this function? What are we trying to find here? Yes. Okay, yes, we are trying to find the input, right? So what represents input here? X. So your x represents the input here. Okay, so we are trying to find the input here. Okay, and what is this f here? It's a name for a function. Okay, and the name of a function can be anything. Okay, we can use a g, h, x, y, a, b, c, d. Okay, it's not always f. We can use anything for the name of a function. Okay, and f of x combined is the output. Okay, f of x combined is the output. And we also have y. We can also use y to represent our output. So f of x is same as y. Now here we are asked to find the domain of this function. Now it's true that we need to find the input. Okay. Now what kind of input we're gonna have here? So what kind of input are we talking about? Yes.
So it's like solving the bottom part, can I equal 0?
Okay, that's the very specific for this example. Like in general, what kind of input are we trying to look? So what is that input? Is that a name? Is that a number? Is that a things? What is that input in this case? Yes. So we have a function and our input is x, right? And x is it can be any number, right? So we have the option. So we have a number from negative infinity to positive infinity. Okay, so this is what we have from negative infinity to positive infinity. So we have this infinite number, and from here we need to make a list of number. Okay, we need to choose our input that give us output. Okay, so you choose a number that is your input, and if your input gives you an output, then your input is a domain. Okay, but every number is not a domain. To be a domain, once you choose your input, it must give you some real output. Okay, now for this function, what kind of number can we choose? Now what happens, let's see what happens if we choose our x equals to 3. Okay, let's check whether 3 is the input or not. So in order to check, so what do? We choose our x input to be 3, okay, and check whether we get a real output or not. So you substitute 3 for every x, so you have f of 3 equals to 2 over 3 square minus 9. So we have 2 over 3 square is 9 minus 9, and we have 2 over 0. And 2 over 0 is undefined. This is not a real number. Okay, so when we choose our input to be a 3, so when this 3 is our input, our output is not real. If this is the case, then is our 3 our domain for this function? The 3 is not a domain. Okay, so to be a domain, once you have your number, that number has to give you some real output, then only your input is a domain. Okay, now from here, so this is our rational function. Now we have the denominator. So if you have a rational function, we have very specific ideas here. So we look for a number that make denominator equals to 0. So if you have denominator, okay, so if you have a fraction function like this, okay, if you have a rational function, to find the domain, at first we find a number that make denominator equals to 0. Now what are the number that make denominator equals to 0 here? 3 is the one, right? We know 3 is the one. Do we have any other number that make denominator equals to 0? Negative 3. Okay, so if we choose our x equals to 3 or negative 3, we get 0 in the denominator. That means it is undefined. That 3 and negative 3 are not the domain. But what about the remaining number? Are the remaining number domain for this function? are we allowed to choose any other number other than negative 3 and 3 and we get a real number? Okay, we can check. Let's check for 0. Okay, so if you choose x to be a 0, so if we choose x to be a 0, what happens? Let's see. So when your input x is 0, so f of 0 is 2 over 0 square minus 9. We have 2 over 0 square is 0 minus 9, and we have 2 over negative 9. This is a real number. Okay, it means whenever your input is 0, our output is real. It means that this 0 is a domain for this function. Okay, so this is a rational function, and whenever you have a rational function, you look for a number that make denominator equals to 0, and those number are not the domain, but the remaining number are domain. Okay, so from this real number, so we have this real number here. Okay, so we have this real number. So out of this real number, so our two number negative 3 and positive 3 are not the domain. Okay, so if these are not domain, what do we do? Do we use a closed circle or open circle? Open. So if these are not the domain, we have to exclude. Exclude means we're gonna use the open circle at negative 3 and open circle at positive 3. Okay, so every number other than this 3, okay, so every number on the left of negative 3 are the domain. Okay, in between negative 3 and positive 3, these are the domain. Okay, and any number on the right of 3 are the domain. Only two number negative 3 and positive 3 are not the domain. Now let's write each part of this number line in an interval notation. So the first part is from negative infinity to negative 3. Okay, second part is from negative 3 to positive 3. Since we have an open circle, we are using a parenthesis. Okay, we are excluding, so we are using parenthesis. And for the last part, we have from 3 to positive infinity and parenthesis. Okay, so we have a 3 set. So since we can have any number from first set or second set or a third set, so we're going to combine these using a union. So our domain for this function is from negative infinity to negative 3 union, from negative 3 to positive 3 union, from positive 3 to infinity. Okay, so any number in this set are the domain for this function. It means if we choose any number from this set, we get a real output. Okay, okay, so let's do one more. Okay, so this is number 64. Okay, do you have any question on this one? Okay, let's go to the number 64. And the 64 has a function f of w. Okay, so we have this function, and this is square root of negative 4 negative w. Okay, so this is the function, and we have a square root here, so this is the square root function. Okay, and we are trying to find the domain here. And what is the input here? What do we have as an input? Our okay, so w is the input, so this is the input. Okay, and f of w combined is the output. F is a name for a function. Okay, we are looking for the domain, so it's the same thing. We are looking for a number that give us a real output. Okay, and we have a number from negative infinity to positive infinity. Okay, so we can choose any number from negative infinity to positive infinity. We make a list of every number that give us a real output. Okay, since this is a square root function, so what kind of number do we need to have under a square root to get a real number? So we have a square root. What kind of number do we need to have under the square root? It has to be positive or 0, right? It can be 0. Square root of 0 is 0. So we can have a 0 or positive. So that means whatever expression we have under this radical sign has to be equals to 0 or greater than 0. That is, we have an inequality here. So the expression is negative 4 to, so negative w. This is what we have under the radical sign. Okay, this expression, this is one number. This number has to be greater than or equals to 0. okay, then only our square root of this number is defined. Now we have this inequality, we solve, and the solution of this inequality is the domain for this function. Now how do we solve? We add 4 on both sides, okay. So negative 4, positive 4 cancel. We have negative w greater than equals to 0 plus 4, 4. We have negative in front, so we need to get rid of negative. So we divide both sides by negative number. And whenever we divide by negative number, do not forget to flip your inequality. So we have greater than, so we have less than equals to negative 4. Now in a number line, so we have positive infinity, negative infinity, we have negative 4 here, somewhere here. Now at negative 4, is it closed circle or open circle? Closed, right? Because we have equals to sign here, so it's going to be a closed circle. Now where do we find a w which is less than negative 4? On the left or on the right? On the left. So every number on the left of negative 4, including negative 4, is the domain. So the domain is from negative infinity to negative 4. With infinity, it's always parenthesis, and with negative 4, we have a closed circle. It means you're going to have a bracket. So any number which is less than or equals to negative 4 is the domain. It means if we choose any number from this set, we get a real output. Okay, if you choose other number, we get an imaginary. Okay, we get a complex output. But we want a real output to be our domain. Okay, get with this one. Okay, now let's let's finish the one more example. Okay, not one more example. So we have one more function, and I didn't mention that on our handout. So we have a piecewise function. Okay, so that's something I'm gonna add on a handout here. Okay, try to create a space on your handout. Okay, I do have enough space for me. Okay, so the next topic before the last example. So I want to talk about the piecewise function. Okay. Piecewise function. So this is the one more topic for this section 2.3. Okay. Okay, now here, so this is a function. This is also a function. Okay. But this function has different pieces. Okay, we have a different output for different input. Okay, now let me take so we had something like f of x equals to x plus 2. So this is a linear function. And what is the input for this function, or what is the domain for this function? Can anyone tell me what kind of number we can choose for x? All real number, right? So from negative infinity to positive infinity. Now here, for this input, okay, for this input, we only have one function, okay, we only have one output. Now in a piecewise function, we have a different input, and for different input we have a different output. Okay, now here we define a function. Okay, so let's call, I have a function f of x. Okay, I have a function. Okay, we have seen this is absolute value of x, right? So we have this absolute value of x function, and this function is equals to x, okay, if x is greater than equals to 0, and negative x if x is less than 0. Okay, so we have this absolute value function. Okay, now this function has a two output. Okay, the very first output is this absolute value of x is equals to x. Okay, if your x, which is the input, is greater than or equals to 0. So if you choose your input to be equals to 0 or greater than 0, then you're gonna use this expression to find the output. Okay, now the same function, okay, the same function, absolute value function, it has a output negative x, okay, whenever your input x is less than 0. So you have an input, a number which is less than 0. Then in that case, you're gonna use this expression to find the output. Okay, Now here, for this function, let me choose my input and find the output. So if input x is equals to 10, now what expression do we choose to find its output? We have a two. We have this positive x, okay? So we have this output positive x, and we have this output negative x. Now when our input is 10, which expression do we choose to find its output? The first one, right? The reason is that our input is 10 and 10 is greater than 0, so we choose this expression, so which is simply x. So our absolute value, so absolute value of x is equals to x, okay? And this is, now let's find the absolute value of 10. So absolute value of 10 is equals to 10. Okay, this is the output. So whenever your input is 10, we get output equals to 10. Okay, now let me choose input x equals to negative 4. So here our input is negative 4. Now what part of a function do we choose to find the output, first or second? Second, okay? And the reason is here, so whenever your input, so this is the input, okay? Whenever your input is less than 0, then we're gonna choose this expression to find the output. So let's write, so our absolute value of x is equals to negative x in this case. And what is the reason? Because our input is less than 0, okay? And so absolute value of negative 4 is, so we have negative as it is, and our x is negative 4. So we have negative 4, and we get negative times negative 4, we get positive 4. So on the basis of your input, we have to choose the output, okay? So here we have a different output for a different input, and this kind of function are the piecewise function, okay? Okay, let's do one more example. Do you have any question here? And we'll do similar example, okay? So our function, we have a h of x. So this is a function, piecewise function, okay? And this piecewise function h of x is equals to 1 if, so h of x is equals to 1 if our x, which is input, less than 0, okay? And this h of x is negative x plus 1 if our x is greater than 0 and less than equals to 2. And this same h of x is negative 3 if our input x is greater than 2. So for different input, we have a different output. So whenever you choose a number x which is less than 0, your output is 1. Whenever you choose a number input in between 0 and less than equals to 2, your output is negative x plus 1. And whenever your number is greater than 2, then your output is negative 3. Now, here the question is, what is h of 2? So we are trying to find h of 2. So here, finding h of 2 means, are we finding the input or output? The very first thing. So we are asked to find h of 2. Are we asked to find the output or input? It's the output. So if this is the output, so if we are asked to find the output, then input has to be given to us. So what is the input here? 2. So 2 is the input, okay? Now, what expression do we choose? What expression do we choose to find the output here? Where do we find 2? Okay, 2 is not less than 0, right? So we do not use this one, okay? We have a 2 is less than or equals to 2. So our x here, which is 2, is less than or equals to 2. So we have equals to 2. It means we're going to use this expression to find the output, okay? So for this input, so our h of x is negative x plus 1, okay? So we substitute 2 for every x. So we have h of 2 equals to negative 2 plus 1, and negative 2 plus 1 is negative 1. So when you choose your input to be 2, your output is negative 1. Okay, the next, let's find h of negative 6. So what is h of negative 6? So what is h of negative 6? So where do we find this negative 6? Is our negative 6 greater than 2? Negative 6 is in between 0 and 2 or less than 2? Less than 0. Our negative 6 is less than 0, right? So it means negative 6 is less than 0 means our h of x is 1. So our function that we're going to use is h of x is equals to 1. Okay, now we don't have an x variable on the right side here, so it means these are a constant function. Okay, and h of 6, there is nothing to substitute for x on the right, so it remains 1 as it is. So 1 is the output. Okay, so we replace, this is negative 6, so we replace x by negative 6, and on the right side there is no x term, so there is nothing to substitute. Okay, so 1 is the output. Okay, for the next number C, what would be h of 0? Now, so what is h of 0 here? So where do we find x? So our input is 0, okay? Where do we find input 0? In the first, second or third interval. So where do we find 0? So this x less than 0 is same as from negative infinity to 0, okay? And this is same as 0 to 2. Do not get confused. And this is same as, you can just write in an interval notation. Now, in which set do we find 0? None, right? It means this function, the function at 0 is undefined. Okay? So h of 0 is undefined. So h of 0 is undefined. There is no output. Okay. Now, for the same function, okay, let's do one more, then we'll go do our last example. Okay, let me take the example from our book. So you have 39 as a homework. So, okay. So let me do 40. Number 40, okay. So this is from our exercise number 40, and we have a function f of x. F of x equals to 0 when your x is, if x is less than 0, okay, and f of x is 2 if x is greater than equals to 0, less than 1, and f of x is 4 if your x is greater than equals to 1. So we have this function f function, piecewise function, okay, and this piecewise function has a 3 different output for 3 different input. So when you choose your input to be less than 0, your output is always 0, okay. When you choose your input to be greater than equals to 0 and less than 1, your output is always 2, and when your input is greater than equals to 1, your output is always equals to 4. Okay, now if this is the case, okay, correct me if I mispronounce your name, okay. Let me start from Peter. Can you help me? So let's find out. So what would be, okay, so I want you to answer what would be f of 0 here. What is f of 0? Okay, now here, okay, that's not the correct. Now here, okay, so f of 0 means your input is 0, right? Now we look, where do we find 0? Do we find 0 in the first set, second set, or a third set? So where do we find 0 in the first set or second set or third set? So first set is x less than 0, so your input has to be less than 0. Second set, your x is greater than equals to 0 and less than 1. Third set is x is greater than equals to 1. So we find 0 in the second set, right? So it means 2 is the output for this input. Okay? Okay. Okay, Mason is not here. Do we have okay. The next, Christina. Okay. What would be f of 10? F of 10. That's right. Okay, 10 is in the third set, and the output corresponding to this input is 4. Okay, that's good. Colton. Okay, this okay. F of 1. What is f of 1? 4. Okay. Yes, that's correct. So our 1 is here in the third set, and the corresponding output is 4. Okay. Next we have here Alessandro. Okay. What is f of negative 4? F of negative 4. 0. That's correct. Tylee for you. So f of negative 10. Okay, that's good. Alicia. Okay, f of 1.5. Okay, so 1.5 is in the third set, right? We have a x greater than 1, so 1.5 is greater than 1, so 4. Okay, I missed. Okay, now Vanessa is here, right? Okay, so for you, so what is f of negative 0.5? That's right. So negative 0.5 is less than 0. So this is in the first set, and the corresponding output is 0 here. Okay. Okay, the next we have here. Okay, Marcus.
Yeah.
Okay, f of 20. Mm-hmm.
4.
4. Okay, Sergio.
Yes.
F of 100.
4.
4. Okay. It's Kaylee or Kylie? Kaylee. Okay, Kaylee. F of 1 over 2. 2. Okay, that's good. Robot. Wait, okay, that's you. Okay. F of 2.5. 4. Okay. Eliza. Okay. What about f of 9? 4. Okay, good. Logan. F of square root of negative 1. Okay, that's true. Negative 1 is a imaginary number, right? Square root of negative 1 is an imaginary number, and we don't have a domain here, so that's undefined. That's good. Okay, Michael, what is f of 15 now?
F of 15.
4. That's good. Okay, now, okay, I did miss here, so you didn't sign up the attendance sheet. Who do I miss? Okay, Ivan, right? Okay, so for you, so what is f of negative 10?
Negative 10 is going to be 0.
0. Okay. Did I miss anyone else? Can I get your name? Essays. Okay. What is f of? Okay, let's go with 50. F of 50. 4. Okay. Good. Did I miss anyone else? I think I missed you. Okay. Can I get your name? Ashley. Okay. What is f of negative 20? Negative 20, 0. Okay, that's good. Justin. Okay. F of 0.9. 2. Okay, good. So we are good with this one. Okay, now let's go to our last example. Okay, and in the next section we'll be talking about the graphing. So we'll have this piecewise function again. Okay, in the next section. Okay, now let's go to what we have in the last example here. Okay, let me erase all of these. So here we have. Okay, now we have this picture. Okay, bar diagram. And it gives us the average high temperature in Fargo, North Dakota in degrees in Fahrenheit, okay, as a function of the month of the year. So we have a average high temperature, okay, and this average high temperature is a function of the month of the year, okay. So function of the month of the year means, can you so what is the function here, what is the input here? So this is a bar diagram, okay, and this gives us the average high temperature, okay, and this gives the temperature as a function of the month of the year.
You should be input.
Yes, what is the input here? So what do we input? So what do we have as an input here? Month of the year, that's right. So we have our function of the month of the year, means the month is the input. So we choose our input month, okay, and we get the output from this bar graph. Okay, now the very first question. Let Tm, okay, so we have Tm be the function represented by the graph, okay, so T is a name for a function, and M is the month of the year. So what is T of May?
7.
Okay, so May is our input, right? So we look for the May. So this is May here, and the corresponding and the height of this bar diagram is the output, okay? So the height of this, okay, now is it like 70 closing? Okay, so the height of this bar diagram is 70. So 70 is the T of May. So your input is May. So you choose your month, and this bar diagram gives you the output, okay? Now what would be the T of September? So your input is September. So you look for the September, okay? So we have this input, okay, and your output is given by the height. Okay, this height is the output, and the corresponding height is still 70, right? So from here, so your x, okay, your input is always x, okay, x coordinate is your input, and the y coordinate is your output, okay. Now let's go to the number B. So what are the valid input values for this function? So we have a T of M function, okay, so T of M function. Now for this T of M function, let's find the domain. What is the domain for this function? What kind of what kind of things, or what kind of number, or what can we choose for our M? M is the input here. So what can we choose for M?
Months of the year.
M is the,
Months of the year.
okay, it's the only the months of the year. So we have like 12 domains, okay. We can't choose a number. Like if you are asked to find T of 10, then that is undefined, because 10 is not the domain. Your domain is M, and M is the month of the year, okay. So T of 10 is undefined, but we can find the output for each of these 12 months here, okay, with the help of this bar diagram. Okay, this one is easy. So the valid input values for this function is month of the year, okay, 12 month of the year. Okay, so let me go to number 46 from our exercise, okay, and this is pretty similar to 45, and 45 is your homework. Okay, so this is gonna be number, okay, before that let me do number 44. So in 44 we have this table, we have a T, okay, we have H of T. So we have H of T. So when T is -2, our H of T is 4. When T is -1/2, our H of T is 4.5. When it is 0, it's 2. When it is 3, it is 4/3. And when T is 4, our output is -1. So this is 4. Okay, so this is the H of T function. So our function is H here, okay. So H is the function. And what do we have for our domain here? What is the domain? What do we use here? What is the domain here? T, right? So T is the domain here. Okay, this T is the domain here. And this H of T combined is the output, right? Is the range. Now, from here, can you tell me what is H of h of 0 equals to, from this table, what is h of 0? 2, right? It means when your input is 0, we are finding the output, and that is 2. Okay, so this is 2. So what about h of 4? So what is h of 4? So you are asked to find the output. Okay, your input is 4. So when your input is 4, your output is -1. So -1. Okay, now, so for what t value your output is 4.5? So you are, okay, now here, so if h of t is 4.5, what is t equals to? So here, what are we asked? Are we asked to find the input or output? So we are asked to find the input, right? We are asked to find the t. T is the input. And we are, so if you are asked to find the input, you must be given an output. So this is your output, and output is 4.5. So when output is 4.5, our input is -1/2. So t is -1/2. Okay, one more. Now what about h of 5? What is h of 5 here? That's true, because our input is 5 and we don't have input 5 here. So we have -2, -1/2, 0, 3, 4. There is no 5. So this is undefined. Okay, h of 5 is undefined. Okay. Okay, now the next, this one is easy. Okay, now let's go to number 46. So in number 46, okay, so we have a 3-part here. So we solve for x, okay, and we have x plus 5 equals to 13. So this is the easiest thing, right? Solving this equation for x. So what do? We subtract 5 on both sides, and our x is 13 minus 5, that is 8. So this is solving for x. Okay, this is part A. Now part B, okay, we are asked to find f of 10. Okay, and f of x is given as x plus 5. See, number B, we are asked to find f of 10, and f of x is given as x plus 5. So what does it mean by finding f of 10? Are we looking for the input or output? Output. Okay, and what is the input given to us? 10. So whatever you have inside the parenthesis, okay, whatever you have inside this parenthesis is your input. So when your input is 10, we are asked to find what is the output, and for that we substitute this input for every x in a function. So we have f of 10 equals to 10 plus 5, and we get 15, and this is the output for input 10. Okay. Okay, the last part for this question is, okay, find x. Okay, we need to find x. It means we are asked to find the input such that your output f of x is equals to 20, and your function is same, f of x is x plus 5. Okay, yes, but how do we get that number? Now where do we substitute this 20? 20 is f of x, right? So you substitute 20 for f of x. So you have 20 equals to x plus 5. This is an equation. We solve it. So you subtract 5 on both sides, and this cancel. Our x is 15. So input is 15. Okay. Any question up to here? Okay, now from 47 to 54, we are asked to find, we have to determine whether it's a function or not. Okay, just let me read and just tell me it's a function or not. Okay, the length of a side of a square is the input variable. Okay, the length of a side of a square is the input, and the perimeter of the square is the output variable. Is this a function or not? So your input is the length of a side of a square, okay, and your output is the perimeter of the square. So to be a function, for one length we need to have exactly one perimeter, right? And if we have a one length, we always get only one perimeter, so it means it is a function. Okay, now whatever the person's height is the input variable and their weight is the output variable. So person's height is the input and your weight is the output. Now can a person with one height have a two different weight? Can you have?
Oh, not one person.
Okay, at some fixed time. Okay, so now wait, like if we just take two different time period, we can have, right? The height remains same and the weight changes. But if we consider a fixed, like certain time, and if we take the weight of a person with a fixed height, we get only one weight, right? So this is a function. Okay, whatever the price of a stored product is the input. Okay, the price of a stored product is the input and the name of the product is output. So the price is the input, okay, and the name of the product is output. Can we have one price and a two different name of a product? Let's say the price is $10. Okay, can we have a $10 price and a two different name of a product that costs $10? We can have, right? So this is not a function. Okay, the perimeter of a rectangle is the input and its length is the output. Perimeter is the input and the length is the output. Now for one perimeter, do we get one length or a different length? It's a rectangle. Okay, so you have a rectangle, your perimeter is the input. Okay, you input your perimeter and you find the length. Now for one perimeter value, do you get exactly one length or you get more than one length? Okay, now here, so what I mean here, okay, let's say we have this rectangle, okay, and this rectangle has a perimeter 40, okay, and the width is, let me call it 5. Now, will the length be exactly one length or more than one length?
I don't think so.
So what would be the length here? How do we find the length? Okay, let's call length is L. And how do we find the perimeter? We are adding all sides, right? So 5 plus 5, 10 plus L 2L equals to 40. So you subtract 10 on both sides. Cancel, you have 2L equals to 30 divided by 2. Your L is 15. So the length is 15. So for one perimeter, you get a length exactly one length 15. Now with the same perimeter 40, do we get a different length? But what if your width is different? So if it's not 5, if it's 2, do we get the same length or we get a different length? We get a different length. So this is not a function. Okay, the next one here, the input variable is the denomination of a US paper bill, $1 bill, $5 bill, and the output variable is the length of the bill. Okay, so your input is the $1 bill, $5 bill, okay, and the output variable is the length of the bill. Now for $1 bill, do we have the same length? Do we have exactly one length? If it's US $1, it's fixed, right? It's exactly one length. Okay. Next, the input variable is the barcode on a product at a store, and the output variable is the name of the product. What do you think? So your input is the barcode of a product, okay, and the output is the name of the product. Is it a function or not? So for one barcode, we exactly get the one product, right? So this is the function. Okay. Yes. Okay, let's do this much for today. Okay, if you have any question, I'll be